we can break up this construction into a number of steps. The length of the line AB is equal to 10 centimeters. This will be a good starting point. We can use our ruler to draw a 10 centimeter line. Then we can label the endpoints with A and B. The next bit of information is that the size of the angle CAB is equal to 60 degrees. Whenever we have this three-letter notation for an angle, the middle letter is where the angle occurs. Here, that's A. So we'll want to use our protractor to measure out an angle of 60 degrees at A. Once we've measured this angle, we'll draw a faint line outwards. Our final bit of information is that the size of the angle ABC is equal to 40 degrees. Since B is the middle letter here, that's where the angle occurs. So the next step will be to use our protractor again to measure out an angle of 40 degrees at B. We'll draw a faint line outwards in this direction. So, we've drawn out one side of our triangle, AB, and we've measured out the relevant angles at A and B. The construction has already made out the shape of a triangle. To finish off, all we have to do is label our intersection point with C, and then to join this with solid lines to A and to B. In part 2, we're asked to measure the length of the line BC. Well, we have our triangle drawn, so all we have to do is to get out our ruler and measure the distance from our point B to our point C. Doing this gives an answer of approximately 8.8 centimeters. So this is what we'll write into the answer box. To find our angles, alpha and beta, there's two key facts we need to know about parallelograms. The first is that opposite angles in a parallelogram are equal. The second is that angles which share a side in a parallelogram always add up to 180 degrees. In our parallelogram, the angle alpha is opposite the angle of 115 degrees. Since opposite angles are equal, this means that alpha will be 115 degrees. If we focus on the side SP in our parallelogram, we'll see that beta and the 115 share this side. Angles which share a side must add up to 180 degrees. This gives us an equation that beta plus 115 is equal to 180. If we subtract 115 from both sides, we get beta is equal to 180 minus 115, and this comes out as beta is equal to 65. We're asked to show that the triangle PQR is congruent to the triangle RSP. To help visualize this in our diagram, it will be a good idea to join P to R with a line. The two triangles we want to compare are PQR, which I've marked in blue, and RSP, which I've marked in red. To solve this question, there's two key facts we will use. Firstly, triangles which share three side lengths are congruent. So if we can show that the triangles PQR and RSP share 3 side lengths, then we'll know they're congruent. The second fact is that opposite sides in a parallelogram are equal. In our diagram, the side SR is opposite the side PQ, so these side lengths will be equal. The side SP is opposite the side RQ, so these two side lengths will be equal. So, let's look at our two triangles and show that they share 3 side lengths. The first thing to note is that our triangles share a common side, PR. So this is one side length that they have in common. We noted earlier that the length of SR is equal to the length of PQ. This was because they were opposite sides in a parallelogram. Also, the length of the line SP was equal to the length of the line RQ. Again, this was due to the fact that they were opposite sides in a parallelogram. Since we've argued that our triangles share 3 side lengths, we can conclude that they are congruent.